see that it's actually working on YouTube, and we can start. Andrew, how is it going? You got everything covered now?
Everyone.
Yeah, like.
Okay.
Everyone is covered.
All right. I see us live on YouTube. I think we're good. So ho
Cool.
everyone.
Where is my? I had a sweater.
You see, I'm an official sweater of this 2021 year. Welcome everyone. That's our 17th session, and this session finalizes this year of X technology events, I think. And we have a very special session, as usual, by the way. But this time is actually Andrew. Andrew was our show master on the third event, I think. He showed the Goose Ops project. And today is something similar, but in a different area. So the Goose Ops, as you might remember, was a DevOps area, and now it's more about programming, microservices. Yeah. Andrew, mic is yours. Maybe you want to share a screen.
No, thank you.
Yeah, that's fine.
Yeah, thanks, guys. I'm really happy to be there once again. Unfortunately, after my last speech, I lost my voice for three months, and now I'm fully recovered, so I can continue with you.
Was it because of Goose Ops or something else?
Yeah, because of tricky questions I received during the live streaming last time.
When you already dropped?
Yeah, my voice just disappeared after that, as well as internet. So yeah, let's get started. I'm not sure. Are we still on the page to introduce X technology, who we are, and what we are doing and what for? Alex, is it still on track?
Yeah, I don't know. Sure. Maybe just a few words. Why not? Yeah. You want to? Someone wants to introduce, or I can do that. Yeah, it's sorry for that question. I can do that. Yeah. I think if you missed our previous events, you might not know what we're doing. We basically a collaboration of people. We working on open source projects. We combine it with educational streams, maybe some, I don't know, live coding, basically streams. Streams is just for us to present and challenge our projects against you. That's also a way for us to promote our project. But I think two main goals for us is to explore some technologies and help each other to explore them as well. And we are on different areas. We operate in different areas. We mentioned already DevOps, programming. We also have a very strong, by the way, data science part in our group. Today's Igor is one of these data scientists. But that's I don't know. That's kind of it. That's what we're doing.
Thanks, Alex. Yeah. So let's move on with TimeMate and have a brief understanding what's the idea behind it and what's on my mind, basically. Yeah. So today I gonna introduce TimeMate project as well as take a brief look at the GRPC protocol. Also, we're gonna have a quite quick look into the homebrew package management for macOS and understand how we're gonna how we could publish our applications so they will become available for everybody. We also aim to kind of look into the design of architecture of this system, so having a look into the interfaces and plugins, and also we are aiming to look into the plugin system which is introduced by Go language and some third parties, and actually pick one. To be honest, I already picked one for myself, but just need to discuss it with you guys. So what is TimeMate? So let's start from the problem it solves. So I'm a software engineer, and also I'm a TF consultant in various of companies all around the world. So my daily job is just doing design, discuss, build web projects and microservices architecture. However, there is one thing I don't really like in all this stuff, which basically happens at the end of every month. So you have to sit and prepare all your invoices, all your bills, taking care of reports for all these customers and make them send to them. And usually this process takes me almost 1 day or even more. A part of that, I saw some of the customers requires to send them like daily reports, weekly reports, or even track your daily activity in some third-party things like Jira and YouTrack. Yeah, so I'm paying for a bunch of tools now to get all this work and still spending 1 day, 1 whole day or a month, which makes me really disappointed. So the idea here to automate this process, this 1 day of processing different systems and put it into the pluggable system, so all the process can go smoothly from the beginning till the end in some appropriate time for you. So yeah, let's have a brief look on this diagram. I made it earlier. So we have a bunch of data sources which can gain some information to our platform. I personally use this tool for time tracking. Maybe others use other tools. So yeah, the idea here to build a common interface on time tracking API, which allows you to plug a tool you want to plug in here. So for me, it will be like Toggle. For somebody else, it will be Clockify, which is a competitor of Toggle. For another developer, it will be another tool. And the idea here to provide these developers a common interface, which them can use and adopt and build a small plugin, plug it into this system and start using it as they want to. Yeah, another part of this idea is a sync API. It allows you to synchronize all the gathered information from data sources and push it to the Jira, YouTrack, and all other customer software they want to see your time tracking as well on this side. So in some particular moment of time, you go to the reports. It could be, as I mentioned, it could be like daily reports, which I had one customer which wants to receive like daily reports in Telegram, like what you've done. So basically the idea, you have all this time tracked here. You have like 5 activities during the day. You spend some time on each of it. These activities come here, and then it just generates a report if you wish a daily report, and it gets sent through the notify API to the Telegram to this particular customer. So yeah, here for reporting API, I'm considering Google Docs, free version of Google Docs, which allows you actually to upload the Word file, and then you can use API to get XLS or PDF version of this file, basically downloading report. So we don't want to build every single thing here. We don't want to build really generation report, or we don't want to build like timer here, which gathering your time. reports. We want to build some automation on top of existing tools, which allows you to combine all these tools together and start them working for you for free. Yeah. In some moment, so we generated some report. We get it sent to the customer via appropriate channel. Then, in some moment of time, usually it's end of month or some desired date from the customer. They want to receive a invoice from you. So they want to see appropriate paper in the email, and this paper getting paid to your business account. Yeah, so one more thing to mention, once a year you have to handle all the tax thing. If you're a self-employed person, or if you are running a business, this is a thing must have. And it's also a thing to be considered here, to have a kind of a pluggable system. So for example, I will develop some plugin for Russian tax offices, so it will allow me to send reports once a year to them in Russia. But if another developer will decide to do the same for Philippines, for example, he can build this plugin, insert it into this platform, and it will start working for the Philippines as well. Okay, guys, I just had a quick look into the idea, what it should be. Any questions on that?
Yeah, thanks for giving time for questions. I know Igor was preparing some questions for business part.
Yeah, I mean, not like business, but about the product. So I mean, for my side, the most time-consuming part will be trying to unify all the initial sources to your project, right? So because for every app like Calendar, Toggle, or Clockify, you have to prepare a separate connector, or what's the idea?
Yeah. So the plugin itself, basically we have some kind of an interface here. So we expect here to receive like ID, description, tags from any of these source. Some of the data can be empty, but if you decide to implement this plugin, this is how you need to do this. You have an interface, which here you need to provide data according to this interface. And here, yeah, for Toggle, I just took an API connection or whatever, like existing tools, and just started gathering this data for these tools and send it in here.
Yeah, sounds good. Because yeah, I mean, probably not all of these tools have an API, like an open API for everyone.
I compared a couple of them. So, I mean, the most popular ones they have, yeah. But yeah, if they haven't, if they doesn't have, that's
You're not gonna parse them.
Yeah.
Mhm.
Yeah, that makes
Did
sense.
you guys consider any alternatives? Like, I mean, this whole system, it looks like it's solving your personal issue with the time tracking and with the reports. So it's a real issue. It's a real thing that it's solving. Did you consider any projects that can solve it for you already?
Yeah, so some of them could, even Toggle could do some stuff of this. So it could do reporting, and it could send this reporting here. The price is about like $50 per month for such a big feature, to having all this stuff in here. It also doesn't have any billing, no taxes, no synchronization with other sources. So basically, they have only these two. I mean, that works for me. Just here, an idea to have some free version of combination of multiple tools you can combine, automate, and work for you for free. That was the main aim for me.
And for you as a user, so let's say if we're speaking user stories, what will be one of the examples? So for example, if you have like a Zoom meeting, this time tracking API should extract the information about this meeting and put it through like all the stages.
The one I've investigated recently, that Zoom can provide this information, so it can gather the description of the meeting, so how it's called, and from the description, using some data science utilities from Eager, maybe it's possible here to determine what task this basically meeting belongs to. So here, when you do synchronization, you need to understand what the task ID here you need to push this wrapper to. So basically, if you have a daily meeting, I don't think you could push it here because it's just daily routine happening to you. But still, this is time you still expecting to get paid for, right? Because this is just, you spend some time on this, like half an hour or an hour, whatever. You're still expecting this money to be received in your billing, as well as calendar events.
I
You
already see
mentioned
some
Russian taxation system. Is that a real thing? You can apply, you can put your report via API. Did you already check that, or it's just a theoretical?
I haven't done any research, but according to the fact that banks can do this and third-party applications can do this, I assume that it's achievable. Even it's achievable not directly to the tax system, but through these third-party companies like banks. The bank, you could do this, I think. But that's basically the question here. You could do this in UK as well. This is one of I checked recently.
I already see one task for data science. So if you're working on multiple jobs, your data science should take care of it and not to leak the data from one job to another. Let's see. When
Yeah,
you're
and
sending
basically,
reports.
I mean, for example, you have 3 customers and you share your time like 30% per each, and you have different rates on every customer. You have different schedule and so on. Whatever you work for one customer, you work at the daytime, for another at the nighttime or whatever. And all this
Typical
stuff,
life.
should be combined and get paid for. If you do this manually, it's gonna be a mess. Trust me.
And what's the idea about the whole system? Where should it be deployed? On is it like a locally locally served application?
It's a good question actually. So we can go further to the next part, and I will answer this question. So I've done some MVP of this project, which basically solves the very, very, very big issue for me, which is like gathering data from Toggle and synchronizing it with Jira. That's it, what it does. So I've created a Golang application, which called Toggle Sync. You can install it. You can put some kind of a configuration here, providing like token for accessing this API, and also defining how often this tool should look. Like it checks itself like every day, and it looks in the past for recent 2 weeks and recheck it every time. So if, for example, you have changed the description of your time reporting, or even you change the time start date or end date, for example, you realize that you spent more time on this after a day, and you edited it in Toggle. This tool also pick this up and update your Jira time reporting according to your original reporting in your time tracking tool. Yeah, so it uses also Brew. Brew, it's No. Do you know this or not? I mean, Alex knows this. It's a tool for Mac, probably not only for Mac. You can use for package manager and install anything you want on your computer, like applications. It could be terminal applications or even like desktop one. Yeah, so I've created this theme. We can look into the interface actually and understand. So here's a trackers and sync. We have a trackers interface, which is here like time entry. So I expect from every time tracker to gather information, which is ID, description, start date, stop date, text, and source. So source, basically, this is where this data came from. And here's the tracker API, which implements just one method called get time entries from start date to end date. And it return you a collection of these entries. And another stuff about sync. Yeah, basically it allows you to synchronize tasks. And what is task? We can probably see here. Trackers. No, here. So yeah, task is like some kind of identifier of the task in this third-party system like Jira, and all the time entries we have related to this task. So this job basically executes in here. Before synchronizing, we gathered all the time entries, we process them and determine what task it belongs to, and then we can sync it in here and here and here.
So it's a daemon-like application. I mean, it checks it every, I don't know, every 2 weeks. I think I saw somewhere in the
yeah, it actually checks every 1 day. But it checks in the past 2 weeks. So every day it will check past 2 weeks for the changes. If you change something during your past 2 weeks, it will be updated and synchronized. Yeah, and how it works, let me see. So we have this utility called Brew Services. You can actually run it and see all the services which is executing at the moment on your machine, which is maintained by this Brew thing. Or you don't see anything at all.
It's coming.
Yeah, it's very complicated information. Okay.
Wow.
Here's the main idea. Yeah, you see all the stuff is stopped and this one is running on the background. So every day it does some stuff for you. Yeah, so a little bit about how to publish to Homebrew. It's just in here. It's not here. Here. So you have to create the thing called formula for the brew. It's on Ruby, which is I'm not really familiar very much. But here you can describe what where to take your application from. So for example, I have it from this tag, like this is the latest version of this application, and some installation stuff, which basically executes on your computer when you install the software. And another thing called plist, which adds actually an information into your system that you want to run this application as a daemon in your background. So you can run this application.
I didn't know you can do that with Brew. Is that like a task management, job management system as well as a package management? Because
Yeah,
I
I
think
think
it's
so.
mainly used for package downloading, right? And then installing somewhere some software on your local.
Yeah, I think it uses just standard thing from macOS, which is called playlists. It just publish this playlist in a specific folder, and it knows that some particular application in charge of updating this playlist and taking care of. So it can track all this information later, which application is running or stopped or the same. So yeah, I was really surprised about this.
And a second question, sorry to interrupt, why have you chosen Homebrew to publish and manage jobs with? Is that, what's background? Have you considered any alternatives, or it's just the
Not
simplest?
really. Yeah, I mean, for me, I use Homebrew for everything. You can install whatever you want. Hold on. Then there is a possibility to extend this Homebrew. So here is my formula which I plugged in, and it's really simple for editing, and I can install it and reinstall it in any time I want.
I mean, for me, maybe a natural solution for that would be a Docker. Like you put applications in Docker containers and then orchestrate it with some, I don't know, simple Docker Compose config, for example. Would it work, you think, or you see some?
It will work for sure, but again, you need to have on your computer Docker as well. Like this is another tool, just very common. I have it, but I mean, I think it's mostly related to the theme that Docker is something that you expect to run for your, for example, development purposes. And this brew theme, which created, it's just like a binary, which executed from some part of your system, and it works natively without any involving like external tools like Docker, because Docker also it adds some extra on top of your tool. It will add extra 20% of memory which will be consumed, and some amount of CPU which will be taken.
And in the case of Brew, you just publish, basically the binary, and then you can download it, and it will be orchestrated. That's the difference.
Not really. You publish a code like Go language code. So here, by this link, you can download it and see. It will be inside, like just the code inside.
Okay.
And
So you
then,
have a script to extract it and build and start maybe.
Yeah. So then, when it gets to your computer, this
almost like a
tool
Docker container, right?
Kind of, yeah. Yeah.
Alex is opinionated.
Docker is the second best tool in the software engineering world, right? After Git, of course.
Okay.
I believe so. Yeah. So can we go further, or you have some extra questions?
Sorry. Please go ahead.
Yeah. So next, I actually wanted to understand. So I've created this kind of a tool which does like two of these circles, very simple, very easy, and it does it on your computer. So basically, the problem now, if you close your computer, it doesn't sync anything. But when you open, it will continue syncing it again. So answering your previous question, where to run this platform, it's still a good question. So pre-version, I consider run it as well as this toggle sync on consumer computer. So it will be crafted like a one big binary or multiple binaries, which will be executed on your computer, and you are in charge of managing this and taking care if your computer stopped or running. But if you want to have a don't care about all this stuff, you just can run it in some cloud, and it will be completely the same. But in this case, I think you have to pay something to get covered some expenses for the servers and so on. Yeah. So going further, gRPC, why? The why question, I think I will answer later when we go to all these points and understand that one of the plugins support gRPC, and which is beneficial. But gRPC is also a cool thing to use to really start designing your application without writing a code. I mean, without writing your code application. You start designing your interfaces, you start understanding how your application parts can communicate between each other, and by using some appropriate protocol, basically. So yeah, gRPC allows you to create a client and server applications which know between each other. They know how they need to communicate. They know this protocol between each other. And another, I would say, beneficial tool here, that client and server could be written on completely different technologies. It could be like Node.js plus Go plus Python, whatever you ever imagine to use for this. And yeah, and this will work natively and the same speed as expected. So gRPC actually works on top of RPC calls, and it's based on protocol buffers. Protocol buffers, it's a way to describe your application, your interfaces. And there is a tool called Protoc. Let me show you Protoc. Oh, this one. Here. So this tool allows you to build this proto file and build it for example, Go language. So as an output, you write some descriptions, some definitions, how it should look like, what should be the in, what should be out, what should be inside, and what should be the method of this kind of service you want to develop. And then you run this Protoc command. Basically, I have it here. Here's my proto file. I run it for Go language, and it does simple thing. It generates all the implementation of this stuff which I described here. So the only thing you need to do right after that, implement this method, get time entries, and it's already here. Here, get time entries. So yeah, it gives you an interface, Faker client with a method. So the only thing you need to build this method and basically have this implementation. The same thing for Python or other stuff. While you have this proto, you can run a simple command and it will generate you all the wrappers which you can just use for simply going further. It's kind of similar to Swagger, I think. Alex, I think you love it. Swagger.
Not only me. Everyone loves Swagger, right? Open
Top
API.
third tool?
Yeah.
No, it's Linux top third.
Yes, Swagger kind of the similar tool, which allows you to build all these wrappers and build basically your API connection to some whatever server you want to connect to.
So proto command, right? How you call it? Is that from the box can generate it for any language, or you kind of also need to install some plugins and?
You need to install. So for Go language, I'm not sure where it was. Here. No. Okay, for Go language, I install some specific plugins. I think as well as for other languages, you need to install it. For Node.js, you have to have some specific plugin. So
I had this question in mind, but maybe you will cover it later. So, okay, you describe your service with this protocol, with the Protoc protocol, and okay, that declares how this service will behave. I guess it will be needed when the other service will consume or will use this protocol. Is it true that is it checked basically on some kind of build step that the protocols matching between services? Is it happening or it's not? It's not something.
What do you mean matching or not matching?
Yeah, that's hardest part from your for me in this diagram that you showed, right? There are some services that you need to combine in the final application, and beside writing an interface for each service, you also write some business code from how they bind it to each other, right? And I assumed, I'm not sure because I didn't, I'm not an expert in that somewhere in the build time you can check if actually if this service is reuse interfaces correctly, that they match with the interface that you.
Right. So basically, So basically, we have our main application which uses plugins, and the main code somewhere written in there, and we have all these plugins around this application. For example, data source plugins, and what we give these developers to build these plugins, we give them from here, from the main application. We're gonna have a special folder which will be called like interfaces, like tracker interface. So they aim to implement this interface and follow this. While they do this and follow the interface, this could be executed inside this application as a plugin.
Right. And do they also register somewhere? Like, okay, I'm a service implementing calendar part from, okay. So they also publish what they implement, and you have some check while building the main application. Or, sorry, maybe that's it's totally stupid question. I don't know.
I mean, you don't need to have a check. I mean, you will have it inside your code. So if this plugin implements your interface which you shared with them, and they use this interface, you can make a check. Let me just show you.
Yeah, I think my question is how it understands that it's implementing this interface. Is there some way of packaging these services together with a proto that they implement, and this is how the check is done? Yeah, I'm just thinking about.
So whoa. Here. So imagine I have a package. So here I'm using a package, GitHub HashiCorp Go plugin, and here I will have another package. It will be called like TimeMate Core Interface Tracker, something like that. So this will be imported. This should be imported inside the application and should be used for building this plugin itself. While it's done, the whole system can work. The whole system can understand then that this interface was implemented in this plugin. And I use inside my main application the same interface to check. Basically, here's how it should check. So here's the shared code. The shared code means it's shared between the main application and the plugin itself, which could be located in your repository or it could be located somewhere else. But here you check if this rough theme implements this interface, and if it is, you can call specific methods then. If it's not, you cannot.
Oh, so okay, yeah, I understand that. Then it's programmatically done. So you import it some kind of external library, and then indeed you know if it's compiled or not, basically on this step, because you have public methods.
Right.
Just of trying to follow the original question I had. So the proto basically proto format is not involved anymore after you publish these interfaces, and yeah, services are free to implement these interfaces, but then inside your application you just use some external library that you assume is yeah, implementing the interface, and you don't care about proto anymore in this case. Okay.
Yeah, I mean, proto is mainly needed for designing the application on the early stages we have for now. Like usually for now, usually I do the following: I draw the diagram first and start thinking in proto level, just trying to understand how every service should look like. And during this, rethinking, you still have a lot of changes, and then your final idea to understand what will be the final interface, the final proto for some specific part of your system. Because if you just publish it, other developers start developing it, and then in some moment you decide to change it, it's gonna be a more time wasteful, because it's gonna take a lot of time for many people. I don't want to have it.
Right.
Yeah, I think we can discuss this question further when we go deeper into the plugin system, which I actually wanted to introduce you as well. Yeah. So yeah, here we have basically like two options, I think, maybe more. To build it as a one application, which will be monolithic. I will publish it somewhere, and you can use it. Or you have this option with plugins, which allows you to have your application quite extendable. So while you want some new tool to be executed here, you can implement it, or whatever, buy it for pay for implementation, whatever, and you have it running. So the whole other system isn't changing at all. I think it's kind of beneficial thing to have. Yeah, so let's discuss a bit briefly about plugins in your language. So first and the most used maybe way of using plugins, it's via import statement, which is kind of a thing when you just import in some particular external library into your code, and then you can start using this library to write in your code. When you import this library here, and if it's done as a plugin, it will automatically, or not automatically, can register plugin into your code, and you're going to use it right after that. This way called compile time plugins. Another way is called runtime plugins. Runtime plugins is something introduced in Go language 1.8, I think, and it allows you to use shared libraries. So the libraries which is crafted in specific SO extension, and you can load them into your code and also check if they comply some interfaces, and if it's so, you can start using this external tool, which is built like somewhere else probably. Yeah, so here's an example of such plugin which implements like greeting on different languages. So here we just implement the greeting in English, and here we have a type, we have a variable greeter, and we have a simple method greet, which does very simple thing, says hello. have a way, specific way how we can build plugins. We need to specify a build mode plugin for this when we execute in this build. And here's an example of usage of such behavior. So we have a, again, greeter interface, which has a greet method, and then we load this plugin. We open it from the file system, which is quite simple. The only thing you need to do is just put some specific plugins in some specific folders, and your application can discover them from the file system and can start executing, which is very beneficial, I think. Then we'll audit the thing called symbol, and from this symbol we're trying to understand if it has like this greeter variable, and if it has, we actually receive this variable, and then we, using this variable, we can check if it complies this interface which we described here. So the main reason to understand if it has greet method or it doesn't have it. And if it has, then in Go we can just call this method, and this method will be executed through this plugin system from here. So if we decide to implement another greeter on another language, it will be easy. We just do this. We do another plugin. We put it into the folder. We have here kind of a switch or whatever to determine different languages which we want to greet some person. And right after that, we can use both plugins in our application. Yeah, what are the disadvantages of this way? Basically, the main disadvantage, as I've seen, that it allows you, due to type safety, you are obligated to build the core of your application and all the plugins in the exactly the same version of Go language to have it work. So it seems not very useful. For example, if you have 200 plugins, you have to rebuild it all the time by yourself. And if you consider that plugin can be actually done by third-party developer like community plugin, and it has its own system, like own system pipelines for build, and for sure it will not match your Go language version, and you will have these issues. So the only way just to gather all these plugins into your build system and try to build it all together, which doesn't seem to me very useful to do. And here there is some alternatives you can look at. It's called RPC-based plugin system, and here we're coming back to our GRPC knowledge about Protoc and all this protocol, and try to build plugins which also can be designed using this Proto, which is cool. And another beneficial that it's fully isolated. So anything happens in the plugin code, it will affect only plugin code compared to these runtime plugins. Way if something happens wrong in your plugin, it will fail all your application. And that's bad, I think. Yeah, distribution as well. You can build your plugins which will be located on the same system, on the same network. You can build plugins which will be located on the different machine, and you will call them through the gRPC calls, and that will work. You can scale the system quite easily. If you see that there is not enough capacity on the execution on some particular plugin, you can scale it up and have more instances of the same, and it will be, very cool. Yeah, And also it doesn't, require developers and you to have all these plugins in one space, in one place. So if there is some specific procedure to register this plugin, you can have it from external GitHub repository or external, external tool. It doesn't need to be from your repository.
Nice.
Let's have some questions maybe, and then we can go and look into this HashiCorp Go plugin tool a bit deeply.
Yeah, I think I don't have questions at this point. It looks to me this interface in a code, in a greater code, a little above, it's kind of repeating information on the service itself. So I thought maybe it would be possible to reuse, and I guess some alternatives can use this protobuf, same information, right? But yeah, just thinking.
Yeah, I mean, with Protobuf and gRPC, it's getting easy because while you have this proto file described, it's kind of an interface for anything, for server and for the client. So you can build your core application just having in mind all this proto, and you don't have any plugin at all. You have only proto, you have the client in Go language, which is generated, which can call some particular, third-party plugin, which will implement this proto. So you can write the whole your code. You can even make a test. So there is a couple of ways to mock these plugins. So you can mock and send different results from this kind of a plugin, which doesn't exist at all, and test your application. As well as on the other part, on the plugin side, you can test your plugin, just having the knowledge that it should follow this interface, and test, mock all the environment around it, and test that it works as expected, if you wanted to. Yeah, so let's go then into this example of HashiCorp Go plugin. By the way, they use it for this.
Of Terraform.
Sure. Yeah, from my previous when I was telling about Terraform, we were speaking about Terraform and all this DevOps stuff. They actually implemented this plugin system, which allows you to very extensively extend your Terraform cloud formation. For example, you build some own tool, own API for some particular thing. You can register in this registry and start using it in here in the cloud. And this is implemented through this Go plugin system. Yeah, so if we look into this example they provide, let's go to plugin Go. Let's go to here, also Proto, and maybe. So as a main thing here, we have again Proto file, which has the service definition that service should have like two methods, get and put, and all the description of the input and output for these services. What else? Then I guess they run the same tool Protoc to generate this file, which actually does generate all the information you needed to start implementing. And then we have our plugin code, which basically is here, and it uses some shared information from the information shared with your main core application, which basically interfaces. And we know this k value, and we implement these two methods for our internal structure. For example, it could be working with database, it could be working with memory, it could be working with some whatever queue, and like 3 different plugins we can implement on top of this, which just had 2 methods, put and get, and does some internal implementation of this. And then we say like, okay, plugin, we want to serve this plugin, and we need to register this plugin by this name. So basically, the server knows how to determine where to look this plugin. By this name, this plugin will be accessible from the server as well. Yeah, so here we create shared KV GRPC plugin. Let's have a look. What is that? And maybe like this. Yeah, so it's a shared interface, which basically includes some internal gRPC stuff and also includes your implementation of k-value storage, which can be implemented like you wanted to. Here we have a registration of this Protoc as a server, as a client, and we let me find Protoc. Yeah, using from Protoc file register k-value servers. So this code was generated earlier from our Protoc file. We start implementing our existing application. And at the end, we have our code, which does run this. We use this plugin as a separate program. So it basically starts this server. We know that by this specific name of the plugin, accessible somewhere on our network. We'll kill it at the end. And then we have pretty much the same. We have a RPC client, which is a client which allows us to, call just simple methods from this gRPC server and command. We know that here we want a specific server by name, which is called KV gRPC underscore gRPC. When we receive it, we also need to match to check if service matches this interface we wanted to have. Like, does it have 2 of these methods like get and put? And if it does, we can start using it. So we can start calling kv get or kv put, and once on the background, again, compared to this previous example, here we're just calling everything inside the app through the internal shared library API. And here, when we call get, not that. So anyway, yeah, here when we call get, actually what happens, we call the external tool, which is located, which could be located even on a different computer. And this call happens through the network. So client has your message. So what you have to say to this external package, it compacts it into the bytes. It sends these bytes to the network. On the server side, which is a plugin implementation, it unpack it into the same struct, inside the Go language, and then it can understand, okay, I have this input, I need to do some work and send back some output, so some result. And then it happens just the same. It does the job, it covers it in some response message from Protoc file. Yeah. So we have some response here. So here we will have some time entries. This time entries again packed into this, send back to the client, and client receives and unpack it and see the result. So basically for the application itself, it looks like simple call of simple function, which is just inside your code. But in real, it happens somewhere on the background through the network, which is kind of cool.
I maybe missed the point. Where do you specify how to connect it? I mean, it can be deployed on somewhere.
Yeah. So yeah, the idea how to connect it, it's actually encapsulated inside this Go plugin. So you don't need to take care of this. The only thing you need to take care of, you need to register your plugin with some specific name, and then you can use this specific name to gather specific plugin. So for us, it could be like data source underscore toggle, data source underscore zoom, data source underscore something. And on the plugin side, we just do registration of these every single stuff plugins like that, following this group.
But you need some kind of dispatcher, right? You need someone who knows where to look for this plugin application. It's if I understand that correctly, that happens when you start your main application, and it should have all plugins be connected there. So you need to have this dependency already.
Yeah. I think here in the implementation, the example of implementation, they have kind of a map. Here's it.
Right.
Plugins.
You don't load it with this command stuff.
Yeah. So if you go here, no. Shared GRPC, not here, and here. Yeah, so we have a plugin map. For now, it's just very, very, not very useful stuff, because you have to define all your plugins, but in overall, you can build whatever you want. So some platform on top of this. So plugin map could be some discovery mechanism from the file system, for example. If some files are located in some file system, on your file system in a specific folder, it could be appearing here, and we know that we need to run some specific plugin from this point.
Cool.
1 hour, 3 minutes.
Yeah.
So next steps for this, I just see like I have the very brief explanation what I'm going to build. Any help would be appreciated. I want to build this tool for myself, but also another my aim to discover interesting technologies all together with X technology and these funny guys. Yeah. Any questions?
No, thanks for intro, Andrew. It was a very interesting stuff to cover. I personally have a lot of thoughts and things to investigate. But nice intro. I understand more than before, at least.
That's cool.
I might use your tool in the future, and so for now, I spend, I think, around 10 to 15 minutes every day on putting all the stuff to my current one. Maybe this will save me.
What do you use as your current one?
With Harvest.
Harvest.
I use Excel sheets, but
Yeah.
I
just
don't
don't like. Yeah, I just don't like how it's called, Excel sheet. Yeah,
it's a spreadsheet in Google if you use it
Yeah.
from Google.
Yeah, I'm referring to this.
Yeah.
Cool. But thanks a lot for sharing it.
Yeah, I guess that we can wrap it up, right? We just to announce, please follow us. We haven't decided on the next date yet, but I guess that will happen after New Year, somewhere maybe in January. So please follow our channels to stay in touch. And we're gonna have a small retro in a Telegram group. Let's send some link maybe in the chat. So feel free to join for a couple of minutes. That's it.
Merry Christmas.
Merry Christmas.
Happy New Year.
And a Happy New Year.
Fijne feestdagen.
Yeah. Oh. No.